How do stars die? What if I told you that right now, as you watch this video, stars across the universe are dying in the most spectacular ways imaginable? Some are quietly fading away like dying embers, while others are exploding with the force of 10 billion suns. The death of a star isn't just an ending, it's the universe's most beautiful recycling program. Every star you see in the night sky is fighting a constant battle. Deep in their cores, nuclear fusion creates outward pressure, while gravity pulls everything inward. For millions or billions of years, this cosmic tug-of-war remains perfectly balanced. But eventually, every star runs out of fuel, and that's when things get really interesting. The way a star dies depends entirely on its mass. Think of it like this: the bigger they are, the harder they fall. Stars like our Sun, which we call low to medium mass stars, have a relatively peaceful death. When our Sun exhausts its hydrogen fuel in about 5 billion years, it'll start burning helium instead. This makes the star expand dramatically, becoming a red giant so large it could swallow Mercury, Venus, and possibly Earth. But here's the fascinating part. Our Sun isn't massive enough to keep the fusion fires burning forever. Eventually, it'll shed its outer layers in beautiful, colorful clouds called planetary nebula. What remains is the hot, dense core called a white dwarf. This stellar corpse is incredibly dense. A teaspoon of white dwarf material would weigh as much as a car. It'll shine for trillions of years, slowly cooling down like a cosmic ember. Now, stars that are 8 times more massive than our Sun, they go out with a bang that puts every firework display to shame. These stellar giants burn through their fuel much faster, living fast and dying young. When they run out of fuel, gravity wins the battle in a spectacular way. The core collapses in less than a second, then rebounds in what we call a supernova explosion. The energy released is mind-boggling. A single supernova can outshine an entire galaxy containing hundreds of billions of stars. For weeks, this dying star can be visible during the day. The explosion is so powerful that it can be seen from billions of light years away. But supernovae aren't just cosmic fireworks, they're the universe's greatest gift to life itself. During these explosions, the incredible heat and pressure create elements heavier than iron. Gold, silver, uranium, and many other elements that make up our planet and our bodies were forged in the death throes of ancient stars. Carl Sagan was right when he said we're made of star stuff. The story doesn't end with the explosion. What happens next depends on how massive the original star was. If the core that's left behind is between 1 and 3 times the mass of our Sun, it becomes something almost impossible to imagine: a neutron star. Neutron stars are so dense that a sugar cube-sized piece would weigh 6 billion tons. They're only about 12 miles across, yet they contain more mass than our entire Sun. Some neutron stars spin hundreds of times per second, sending out beams of radiation like cosmic lighthouses. We call these pulsars, and they keep time more accurately than the best atomic clocks. But if the stellar core is more than 3 times the mass of our Sun, not even neutron degeneracy pressure can stop gravity's relentless pull. The core collapses into something so dense that nothing, not even light, can escape its gravitational grip. A black hole is born. Black holes aren't cosmic vacuum cleaners sucking up everything around them. They're more like gravitational wells so deep that space and time themselves get warped. Near a black hole, time actually slows down. What seems like minutes to someone falling in would appear as hours to an outside observer. The most massive stars, those 50 times heavier than our Sun, might skip the supernova stage entirely. They collapse directly into black holes in what scientists call a hypernova or collapsar. These events are so energetic they can produce gamma-ray bursts, the most powerful explosions in the universe since the Big Bang. Every element in your body except hydrogen was created inside a star or during its death. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it came from stellar deaths that happened billions of years ago. Stars don't just die, they sacrifice themselves to create the building blocks of planets, life, and ultimately us. So, the next time you look up at the stars, remember that you're seeing both the past and the future. Some of those stars died long ago, their light still traveling to reach your eyes. Others are still burning bright, but will someday join the cosmic dance of stellar death and rebirth that makes the universe such an amazing place.